Yeah.
So why don't I?
Hi, Hugo. Why did you come? Why did you come?
So it is. It's 6 p.m. So welcome everybody to this. I think it's the second combined TWed and IDEA talk of the fall 2017 term. This is not a data idea seminar. There are data idea seminars are happening on Thursday afternoons. A couple announcements. First, as we try to do with all our TWed talks, this is being recorded for posterity on the interwebs. You'll be able to find it. They'll be in the TWed YouTube channel. And because it's being recorded, keep that in mind. You're welcome to make comments and ask questions, but just keep in mind that it's being recorded. A couple of advertisements. Next week we have the November RPIR users group. Those of you who are within internet distance of me will probably receive an announcement about it. Next week's RPIR users group will be kind of a hodgepodge on software engineering aspects of R. We're going to talk about, we've collected over the past month or so a number of different issues about code structure and calling scripts from things like markdown files, that sort of thing, also talking about collaboration. So it's going to be kind of a hodgepodge. We'll tell you more about that. And as usual, there will be the airing of grievances and the feats of strength. Okay, so we're very honored to have Oshani Seneviratne.
Good job.
I wanted to say it fast. Okay, who's new to us starting this term, and is helping provide some grown-up leadership to our HEALS project in particular. But tonight, Oshani is going to do some work, discuss some of her work that she's done going back to MIT. Is that right?
No, this is the HEALS 1 work.
Oh, HEALS 1 work.
Okay. Yeah.
Okay, so I'll just shut up and turn it over to Oshani. Thank you.
Yeah, so what he mentioned is what I thought I'll be doing, but I thought this might be of more interest to this crowd. As he mentioned, as John mentioned, my name is Oshani. I'm the director of health data research at the HEALS project. So before I talk about the details, I should give a brief overview of the project. So I guess except for a few people, especially Hugo here, everybody else might not know this background behind this project. So the idea or like the goal of this project is to enable a person who might or might not have a health condition like diabetes or hypertension to engage with a conversational agent to get some facts about the type of food that the person wants to eat, type of activities, or anything related to that person's health conditions. How do we do that? So we are using knowledge graphs in the background to power these answers. And how do we create these knowledge graphs? So we are trying to use existing knowledge bases like WebMD, which is mostly in which is mostly in natural language format, and also structured data in data sources like DiseaseSome, even Wikipedia. And then we are also using these cognitive services that are made available to us by IBM Watson. This is mostly in the cognitive agent side of things. So I should mention that most of the things that I'm discussing are very, very early work. So I want this to be more of a discussion style thing. It's not meant to be a talk. And since this is very early work, I want to hear what you think about this work. If you're doing something wrong, or if there's something else that we should be looking at. So that kind of feedback will be very helpful to us since we are at this very early stage. Okay, I have this and I'm using the thing. Okay, so you might wonder why we want to use RDF in dialog systems. So there are, these obvious reasons, like, we want to model the domain knowledge in RDF. And then we want to retrieve the information. So dialog systems are mostly question-based. So you're asking a question, and then you expect the cognitive agent to give an answer. So in the semantic web world, we use SPARQL to query an RDF endpoint. The second thing is inference for complex questions where you might want to do some kind of reasoning and come up with the answer. The third, less obvious one is to actually model the dialog tree. And I'll show an example of what a dialog tree looks like and what I mean by modeling a dialog tree. Okay, any questions so far? No? Cool.
Could you clarify the difference, if any, between a dialogue system and a chatbot?
So dialog system is what powers the chatbot, to my understanding. So a dialog tree will have certain entities. It will have certain intents. And then the dialog tree is the one that actually guides the conversation. So the agent recognizes some intent and also certain entities. And based on those things that the agent recognized, it goes to some node in the dialog tree and then executes the flow from that point onwards. So, okay. So the first thing is modeling the domain knowledge. And so we've identified 4 different types of knowledge graphs to model the domain knowledge. The most obvious one is a disease knowledge graph, since we are talking about health-related stuff. And then personal knowledge graph and diet, and then finally activities. So I'll describe what we've done so far in order to model these different types of knowledge graphs and some of the challenges that we are facing in doing so. So these are those challenges I mentioned. So the first challenge is to get that rich information that's out there in structured form. Why I keep saying that? In natural language format into structured format. So then we have to do some kind of passing from this free form text to a knowledge graph. And then on the semantic website, I mentioned that there are existing knowledge graphs, ontologies rather, are not representative of what we have to do. So then we have to look for what's out there, and then we have to engineer ontologies that we find or do not exist. And then if there are more than one ontologies, we have to figure out where do those things align. So we are spending some time on doing all those things on the semantic website of things. So the last point is, ideally, my point is that humans do not have to worry about creating these ontologies. I wish there was an automated way of doing that. Unfortunately, we are not there yet.
Well, so 20 years ago, everyone was saying humans shouldn't have to write code.
Right. Yeah. But I'm saying, like, no, we are not there yet.
Well, but I mean, so there's an argument to be made that, well, computers can write code that's really terrible.
Right.
Genetic programming is just awful, and there's no way to really optimize it because it's just it's the way it works. I mean, wouldn't machine crafted ontology have the same problems?
It might, but this is my wishful thinking.
Okay.
All right. Any other comments, suggestions?
Well, sort of, kind of, not to argue with Jim, I would never do that. But maybe a way to think of this is humans should not knowingly, should not have to knowingly create ontologies.
Yeah.
Right.
Maybe there are, by their actions, humans are hoarders. The way they organize information, maybe they are implicitly creating ontologies. And maybe all that's left for them to do is put labels on them.
Right.
Maybe the machine helps them create ontologies.
Yeah. Right. I agree. Okay. Oh. So the first task is, tapping into this rich corpus of question and answers by some NLP pipeline, and then come up with a knowledge graph like the one that you see here. So we are in the process of doing that, and Hugo here is actually driving that. So if you have any questions on this, you can ask him. And when we identify these different concepts, we want to be reusing existing ontologies as much as possible. However, there are many different ontologies. So this is one ontology that we found, International Classification of Diseases. So I've highlighted the portion that has diabetes-related information. There is another one for diagnosis, another one for treatment. Not all of them have the same kind of information. So we have to do some manual work to actually align these ontologies together. Yeah.
How extensive is this manual work in comparing ontologies? Is it like look at every single term, or is it just...
Yeah, pretty much. Yeah. Yeah. Any research on that yet?
There's tools to do ontology.
Yeah, like, for example, in BioPortal, there is these mappings. But, it's not available for all of the ontologies that are out there. So you have to do some amount of manual work, unfortunately. Yeah, so yeah, here, like, they were nice enough to say, like, these concepts map to these other concepts in other ontologies. Okay, so the next one is the personal knowledge graph. Remember, we are using using the Apple Health Kit. So remember, this is an Apple or iPhone app that we are building. So we have access to the Apple Health Kit API. So we are getting the data from the Apple Health Kit and then converting that into a personal knowledge graph. And these are some of the properties that's available via the Apple Health Kit. So unfortunately, we couldn't find an ontology that models that kind of information. So we created our own for this. If you know of something, do let me know. So this is a health parameters ontology, and that has some of the features that I showed in the previous slide. The next one is the diet or food knowledge graph. So we found that USDA has a lot of food items, and we used the Settler tool to convert all these tabular data into a knowledge graph. And we are using the health lifestyle support ontology in the conversion. So we are reusing an existing ontology for this purpose. So similarly, activity knowledge graphs, again, we are using the Apple Health Kit to activity knowledge graph. For that, we are using, again, another existing ontology called ontology of physical exercises. This is a pretty good one because this identifies, for this physical activity, these are the muscle groups that are activated. So it goes down to that level of detail. And we found that to be pretty comprehensive. Okay, that's it. Any suggestions? Have I missed an ontology to model any of those things that I discussed?
Oh, so I think it's the sequence of slides is an excellent example of mapping.
Yeah, right.
Particular personal activities, this, that, health, personal health, those sorts of things to existing ontologies. What gaps have you identified so far? And sort of what will be the
right? So I mentioned one particular gap for the personal knowledge graph example. We couldn't find any ontology that sort of encompasses everything that we want to describe. So we ended up creating our own ontology.
Right. So that's the example.
Right. And for some others, like the disease work, there are too many ontologies. And none of them have everything we need. So we have to combine different ontologies. So those are some of the challenges that we are facing. You had a question?
Yeah, so the 4 classes of knowledge graph that you mentioned, is the intent that like their information is all completely disjoint from each other, or it should like the 4 of overlap?
Yeah, it should have for example, like, a person is at the center of all of these, knowledge graphs. Yeah, you're right.
How would healthcare information relate to the knowledge graphs or, where you're looking?
Healthcare information.
Well, there's lots of repositories of information in health systems, in health insurance claims, Medicare.
So
Medicaid.
our scope is not does not include those kind of data, but I can see how that can be used. But yeah, so we'll define the scope. Yeah.
I have some suggestions.
Sure.
I can talk to you later about
Sure.
kind of the like where you might slot everything into,
Right.
so that it makes a bit, so you can make them appear a bit better.
Okay. Sure. Happy to talk. Okay, so we move to the next topic, which is information retrieval. So in question answering systems, there are two types of questions. So one would be a simple factoid type question where the conversation agent would not need any contextual information, and it can basically construct the query based on what the user asks. And then we can construct a query and then run that query and get some answers and display to the user. The second type would be a complex question that you have to take into account contextual information about the user, and also there could be some hidden meanings in the question itself. So for those kind of things, we'll probably have to do some amount of inference. So we are trying to tackle both types of questions. And I'll show some examples. Yeah.
Can you define what do you mean by a complex question? What makes it complex?
Yeah, so I'll show an example. So yeah. So the research challenges in this, I mean, a lot of people have worked on this problem, and there are a lot of implementations out there that tackle this same problem. So first we had to identify the intent of the question. We had to do entity extraction. And then if you're talking about RDF-based, queries or RDF-based data, we have to construct the SPARQL query. There's this question about representing the same information in multiple ways. So that's also an issue. So these are some of the research challenges, and hopefully you have some suggestions on how to handle these things, or point me to some work that had already tackled any of these things. So the first thing is querying existing knowledge bases based on the question that the user asked. So here's an example. So a user might ask, what are some physical exercises I can try? And then you probably want the conversational agent to respond with the answer like this, right? This is not personalized, so some of the exercises might not be suitable for you, but this type of question can be easily converted into a SPARQL query. So here's the workflow that we are trying to work out. So once the user asks this question, we submit it to the IBM Watson Conversational Service, and then it does entity recognition and tells us, okay, we recognize the physical exercise as an entity there. And then we can use a template-based SPARQL query, and then run that on the Wikipedia, get some results, and then provide the answer to the user. Now, we might get thousands of results. So, currently we do not have a way of, doing results at pruning. So it's something that we are thinking of working out in the future. Second type of question would be, something that does comparisons. So the user might be interested in knowing whether peanut oil has more monofat compared to sesame oil. So again, these type of questions can be constructed into a SPARQL query, executed, and then give an answer. So here again, Watson will say, these are the entities, And each of these things, like peanut oil, that has a resource on DBpedia. Monofat, again, that has a resource. More will correspond to a comparison. Sesame oil, again, yeah.
So when you're talking about having these templates that you base your SPARQL queries on, does that mean that the system has to have this like very large set of templates?
Yes, unfortunately, yes, yeah.
And is there like, do you like organize that in like a useful way to make the construction fast, or do you just have to like search through every possible template and see like what one matches best with the keywords you have?
Oh, so when I say template structure, it would be it would correspond to the sentence structure. So another way of asking this same question would be, is peanut oil better than sesame oil? So that would map to a totally different template as opposed to this particular template. Yeah.
So like, I don't know if you're going to talk about this at all, but so like maybe an extension of this would be also it's suggesting like maybe like related articles as well, just like, because I think of like Wikipedia, for example, where I look for one thing and then I go to like 5 other things just because I went to the page, if that makes sense.
Right, so DBpedia is actually Wikipedia in RDF.
Yeah,
right.
yeah. So would your conversational agent maybe want to do that in terms of like also, so like true, you can go look up more here.
Yeah. So I would say that's actually the easiest thing we can do. So we do the entity extraction, and then, without actually answering the question, we say, hey, here's a whole set of, data about this resource that you asked about. So that's very easy to do, actually.
Okay.
Yeah.
Yeah.
Yeah. But you're saying related entities, right? So again, that would be pretty easy to do. And yeah. But you're saying like, hey, answer this, and then also
give me like
yeah, sure, that can be done. Yeah. Yeah.
So does IBM Watson reconcile the entity and scale URL? Are you getting the entity URL back from Watson?
No.
So there's an additional step where you take the entity and
Right, correct.
identify the ID.
Yes. Yeah.
One problem is that I've never heard it called monofat before.
Huh?
Monofat
Yeah.
is not a term that I've heard used to talk about monounsaturated fat.
Oh, it's in the it's on DBpedia.
Oh yeah, I know. I
Yeah.
was just looking, but it seems. So are you doing anything about differences
synonyms? Yeah.
Well, synonyms, but also like making sure that what you're extracting from the knowledge source actually is to the users.
Right. Yeah, we should be doing something like that. Yeah.
We confused.
So you're saying like, what if I ask monounsaturated fat as opposed to monofat, like in this example? Would it perform in a similar way to this?
Exactly.
Right. Yeah. So DBpedia actually has redirects. So I'll show another example here. So in that case, we can check if monounsaturated fat redirects to monofat. That would make up a valid resource that we can actually get data, and then construct the later query, and then run that and get the actual results. That's one way of doing that. Of course, like it might not be that feasible to do that. But the other option is like we maintain all these resources that have similar meanings, and then run or like construct the query for each different. In that case, monofat was the predicate, right?
Mm-hmm.
So if the user provides a predicate that's not on Wikipedia, but we can find some other predicates that are similar to the one that the user provides, we can essentially construct different queries and run and try to get an answer. So that's one way of doing that. I don't know if there's a better way of doing that. Feel free to suggest. But I do realize, yeah, it is something that we have to work out.
I think part of it's going to be curation because there's all these properties in, like especially the nutrition thing where they just shortcut Wikipedia articles as properties, but I don't even, we need to figure out if they actually have a
right
mapping.
Yeah. Okay, so here's another example. So a user might misspell something, And then we want the conversational agent to say, hey, do you mean this other word, right? So again, we can do this with Wikipedia because, like I just mentioned, Wikipedia has a list of potential resources that map to these misspelled words and redirects it to the correct resource. So again, we can construct a query for those kinds of things if we don't find an answer in the first query execution. So it'll find the correct resource or the resource label. Yeah.
So if you've got that mapping, or that kind of that equivalence mapping,
Right.
why not just give the answer and say, did you mean something else?
Well,
so
right.
why not just answer the user's question and also
Right,
say,
right.
did you mean something else?
Right. So we want the user to confirm, right? So this is supposed to debate with the user. So we don't want to give an answer right away because the user might be asking for diabetes with that incorrect spelling, right? We don't know that. So it's better to get the confirmation from the user and then, get the actual result.
What if sometimes you don't have any incorrect spelling? Just the question is kind of vague.
Right.
So, for example, is peanut oil is better? Peanut oil better than sesame oil? So how do you define?
Right. So that that question on the surface it looks very simple, but there's a lot to unpack in that question, right? How do you define better, right? It might not be monofat. It could be some other thing that will make the comparison correct. So we are not handling that kind of question yet. So these are questions that can be directly translated into a SPARQL query using some kind of template-based mechanism. If you have a suggestion on how to handle those kind of questions, do let me know. Okay, so the second one is inference. So here is a scenario. We have a user. That user is obese, and he has already had too many sweet things during the day. And he's wondering if he can eat an apple, thinking that it might be, good for him, as opposed to a chocolate cake, for example. So in that case, just imagine like the conversation agent has to know a lot of contextual information. So that's what I meant. Like, this is the example that I would want to give. And then it has to know what the user ate already. So we are integrating with an app called MyFitnessPal that has all the stuff that the user has done. So we can get that information in a structured format. So in this case, the agent should be able to say that, hey, you've already exceeded the daily allowable sugar content, so it is best not to eat the apple, even though it might be a healthy kind of food. So now how do we do this? So this is a toy example, and this is the ontology that, we are, representing the world for this particular scenario. So we have a concept called food. Food has subclass fruit. Fruit has subclass apple. And then the person wants to eat the food. So when the users ask the agent, can I eat an apple? So it's supposed to create that triple in the system. And then a person has a BMI. A person has already consumed some food. So there's a sugar consumed amount. And the person will belong to a weight classification, and that has different, subclasses. And then when the user asks a question, the agent should give some kind of statement. It could be either a positive statement saying, yes, you can eat the food, or saying, no, you cannot eat the food. Okay, questions? No. So in this scenario, there are a bunch of rules. So the first, or the zeroth rule is subclass transitivity. And then the second one is if the person's BMI is greater than the weight classification's BMI limit, then that person belongs to that particular weight classification. The second rule is that if the person has already consumed some amount of sugar and wants to consume some food with a given sugar content, we add those two and then check if it's greater than the allowable sugar limit for the weight classification. And if it's greater, then we say, no, you cannot eat. You can see like how this plays out, right? So we'll do an inference example here. So we have these data. This is captured by the app. So when the user asks, can I eat an apple or a gall apple? We have these triples generated in the app, and then assume that we have this mock data from reputable study that says, for these weight categories, this is the allowable sugar limit, and this is the BMI limit that defines this category. And then again, this is something that's generated by the app. That this is a person, has this amount of BMI, has already consumed this much sugar, and wants to eat the apple. So when we do the inference, so the first thing is the subclass transitivity. So you saw this. These triples, gall apple is a type of apple, apple is a subclass of food, then gall apple is a type of food. So we have that. And then the second one, so John Doe's BMI is 31, and the sugar limit and the obese category is 30. So 31 is greater than 30, so John Doe is obese. And then the second one is whether the person can actually eat the apple. So again, we do a similar kind of comparison. And finally come to the conclusion that actually eat the apple and should be given a negative statement about that. Questions? Yeah.
So this is nitpicking.
Yeah.
But shouldn't apple be a class?
Apple be a class.
It's a class of things, right?
Yeah, it is a class.
Yeah, but you have but as an RDF type of food. In your
right. Oh, I see what you're saying. So here, instead of saying RDF type, outclass, that it is an outclass and subclass of apple. Is that what you're saying?
Yeah.
Yeah, sure.
There's more than one gala apple.
Right. Yeah. Okay.
Yeah.
Point taken.
Weight class is supposed to brackets or BMI, something BMI over something, then how's that? Should be in brackets, I think. So from the inference, for example, if the BMI was like 19,
right,
it would be a normal class, normal weight, and you'll have two weight classes, not only one.
I'm not sure if I understand. So this person's BMI is over the limit for obese category. But anyway, this is not a compilable set of rules. This is just an example to show you that this is something that we are trying to work out. Okay, any other questions? Cool. So the third aspect of using RDF in dialog trees is to actually model the dialog tree itself. So other dialog systems. So this is what we are working with. We are working with Watson Conversation Services. So this is how it looks like. So we have a welcome dialog node. So when the user first starts the app, it'll say, hi, what can I help you with? And then from that point onwards, the user can ask questions. And then based on the intent, the conversational agent recognizes from the user query, it jumps to a certain dialog node here. And the dialog node has, this kind of thing. So here, sugar level is the name of the dialog node. And here it says like, if the bot recognizes that this question is about sugar level. So sugar level is defined in the intents. This tab here has, the sugar level and how it determines that the user asked a question about sugar level. Then we are saying here respond with, these kinds of answers, right? So the dollar username, it actually binds a variable for the username. And we can actually do very complex things here by using a language called Spring Expression Language. So you can do all sorts of fancy things there. So this dialog node and RDF has so many similarities. So here are some similarities that we've identified. So dialog nodes, they have an identifier, and RDF also, as you know, has a unique identifier, has pointers to the parent. So in the previous case, the sugar level has a pointer to the parent dialog node, which is the greeting. And in RDF also, we have links and relationships.
So the identifiers for the dialog nodes were the things with the hashtags.
Right. Yeah, those are actually intents. So this is the identifier actually.
Oh, okay.
Yeah.
So hashtag sugar underscore level is
right. It's not a global identifier, but within the dialog system, it's some kind of an identifier.
Okay.
There cannot be more than one sugar level dialog node, if that makes sense. Then there are conditions in dialog nodes that determine what node to jump to. And in RDF, we have rules or axioms. And then when it comes to serialization, dialog nodes are serialized in JSON, and in RDF also we have JSON LD. So given that there are these similarities, and because there are certain benefits of using dialog nodes, using RDF for dialog nodes, we thought it might be a good idea to extend dialog trees with RDF. So these are some of the benefits of using ontologies or RDF to model dialogues. So in the current Watson Conversation Services, we cannot really modify the tree. So we have a static tree. And for the application, we expect that when during runtime, it goes through those different dialog nodes to construct the conversation. However, by modeling the dialog tree with RDF, we can expand the tree or prune it based on newfound domain knowledge. And we can customize it based on what the user had previously said. We can aggregate past responses of the individual and also a bunch of other people who use the same conversational agent and add stuff back to the dialog tree. And also another advantage is that right now, like as I mentioned, for the application, it's pretty limited. Like we have this limited set of dialog nodes, but we can maintain a lot of other dialog nodes outside of the application, regardless of those being used in the application itself. And then we can also reuse dialog nodes between applications. So this is the structure of a dialog tree. So there's a welcome node, and there's a parent. In this case, we saw the sugar level, and then it has a bunch of conditions and an output. So what we're proposing is something like this, where there can be different kinds of sugar level based on the user's BMI level. And then we should be able to add these things dynamically. So that's actually it. So if you have questions, I'm happy to answer them, or we can have a discussion as to what other things we can do with these kind of things.
Let's do all of the above.
Okay.
Did you have a RDF representation for the dialog tree, or?
That's what we are proposing. So
It's what?
that's what we are proposing. So yeah,
so you have one already. You're proposing to do it.
Do it, yeah.
So
Okay.
could you actually, so you go back, I think, 2 slides, where you were, okay. So the way you presented this, you said that in the existing conversation services, the dialog trees are fixed, they're not extensible.
Correct.
Okay.
Yeah.
And so is the idea to sort of extend conversation services with some kind of hook that allows you then to jump to RDF, and then you've got the whole world of RDF to work with? Is that kind of the...
Right. So I should clarify when I say it cannot be extended. You can actually modify the tree via API calls. However, it's pretty static in the sense, like, when the application starts, you have to run through the dialog nodes to come up with the conversation. So what I'm saying is, like, given a newfound information, you should be able to modify the tree. I understand that it could require certain modifications to the existing architecture, but it can be done even, we don't have to have this gigantic dialog tree if we want to support a very complex conversation. We can start with something small, and then we can add things as necessary, and then have a more robust conversation with the agent.
I think I understand.
Oh, yeah.
I can see how you can have both. From an application standpoint, it thinks it's kind of fixed, but it's able to, if it's querying a knowledge graph, then it's
right.
Like naturally, dynamically extensible.
Right.
In that space.
Yeah.
So on a similar note, you showed an example of intent being used to respond to a user, but do you guys have any examples of using the intent from a user input? Because that's possible with Watson.
Yeah, so in the response itself, like in the output here, you're saying we recognize some intent, use that in the output. Is that what you're saying?
Yeah, that's what it is.
Yeah.
I was just curious if there was
it's possible. Yeah.
Okay.
And it's there already.
Okay.
You don't have to do anything with that. Yeah.
So the example dialog tree that you showed had a lot of specifics, shall we say? It's a lot. It was basically like a sugar. There's a very So like this is like a really focused on sugar level only, and
right.
And I mean, does this generalize up where you can have kind of a more, so like I don't have something in my head saying if someone's going to talk about sugar, I should say this than this. There's more general, like if I'm going to inform someone about something, I might give them this resource relative to the thing that we're talking about.
So I would say that goes in the response. So is that?
Right, but I mean, so I'm noticing that you have some templating here, but is there the ability to kind of template it further based on using the topic at hand? Or so rather than creating like a sugar level topic or node,
right.
There's like tell person more about this thing where it's
right. So it's how you define the dialog node. So instead of sugar level, you can have something like if the conversation agent recognizes nutrient information from the response, then we can have another condition. If the nutrient information is related to sugar level, then do these kind of things. So you can write complex things in the string expression language I mentioned. You can do that, and then then the node itself will be pretty complex. I don't know if that's what you're getting at.
Well, no, I'm saying what if we keep the node simple, but so have like a reusable node structure that lots of things get templated into it.
Yeah, so that's what I'm proposing here. So at the design time, we might not know what's available out there. Right? So then as we find more information, we want to have the flexibility to dynamically modify the dialog tree. Ontologies provide that flexibility because we have some kind of hierarchy, and we can find more information later that we can add the dialog tree. That makes sense.
Okay, so there has to be explicit nodes in the dialog tree, even if you're dynamically generating them.
Yeah, so I mean, you can create a dialog node, and then you might want to know, okay, what's the parent of this dialog node? So in the case I mentioned here, in the sugar level to obese sugar level and normal sugar level, you might want to know the existing sugar level node. So you can point to that in the dialog tree. So you're basically augmenting existing knowledge in the dialog tree with newfound knowledge.
Yeah, I guess what I was trying to think about is, and Jim hinted at that this might not be available in this implementation.
Right. Yeah, it's not. This is all that we have.
Well, basically the idea that you have an indicator to a disease.
Right.
And the indicator can be good or bad, or trending towards healthy, trending towards unhealthy, and those responses would be, you might have different responses based on healthy and unhealthy, and then it all gets contextualized based on the specific thing that you're doing, but that's runtime.
Right.
Rather than building the.
That's exactly what we want. That's what the inference would allow us to do. In the current chatbot model, you actually have to be very explicit about that. Okay. So you can't have some type. And also remember, this is a tree. So having gone down one of these, you had a next set of just, So having come down, it was a negative health output. You can now say, was it related to sugar? Was it related to fat? Was it related to blah, blah, blah? Is it a weight loss issue? Is it this? So again, as you go down these trees, in theory, they're getting more specific. Because these chatbots,
Yeah. When you mention that interface,
it's just a really nice.
So imagine you've got that the existing editor of the dialog tree.
Yeah.
Okay. And which is kind of depicting this upper part, interacting at that kind of that constructing that upper level. Okay. Now there's a level which you have to extend. Okay. How are you going to make these lower levels and extending the tree more accessible? You imagine it's like.
So honestly, we haven't thought of a UI.
A text editor, or is this is where we select from little.
Right.
Little
so the easiest answer I can give you is we imagine it to be done via some REST API to modify the existing tree.
Okay.
I don't imagine. I mean, I certainly haven't thought of a UI to do this kind of thing, but we can potentially think of something.
In one form, you might have parameterized URIs that you can kind of sprinkle in, and they mean something.
Right. Yeah.
If they're carefully put, because we know we can do that with SPARQL. We know we can do some things. So there's carefully, artisanally constructed URIs that you can put in there that can pull back some useful information.
Right.
But you could also, I imagine, have some kind of interface where you can select these things.
Yeah, yeah.
What's underlying what we saw? There's a language underneath that interface that you showed. What is that?
So it's, I mean, the dialog tree or the dialog node can be represented as a JSON object.
Okay.
Right? However,
what's parsing that?
What's possible?
Well, this is a nice interface for interacting. It's probably creating some serialization, and there's something that's processing that. Something that's
right. So I guess that's IBM proprietary information.
No.
Okay.
Maybe Wei can say what's underneath.
Because I want to know what you would then hack.
So in the first pass of things, I'm thinking of hacking the JSON, like adding to the JSON, structure.
That makes a lot of sense.
Yeah, it's actually done. We can pre and post process, but when we hit certain things.
Right.
So part of what we're trying to do is say, how do we extend it? And then, of course, part of the partnership is hopefully we'll be going back to IBM and saying, hey, look, here's how you extend this ontology. And they'll say to us, oh, that's great. Hey, we'll build it into the tool. Let's patent whatever.
Well, it's nice already that it's JSON.
Yeah,
That's helpful.
Yeah. but there are some limitations. Like, what I described in this presentation cannot be done with the dialog tree as is right now. But at least we can get some proof of concept and, show the utility of this. Then hopefully IBM will agree. Yeah, that's it.
You consider handling the temporal RDF. For example, the example that you mentioned about the Dialog. So the user asked it, can I use the app? Then you inserted that trigger, and then he got the answer no. And now he changed his mind and he's asking about something else.
Right.
How will you decide what triggers will you move?
So that triple has, it wants to eat, I think. Yeah. So the semantics is very different, right? So it doesn't say the user ate a gala apple, right? It's just an assertion that, the user asked this question, so that signals some intent to eat something. But as for the things the user actually ate, we are using an app that the user might voluntarily record his food consumption called MyFitnessPal. So I don't know if that answers your question. I mean, we can remove these triples, but I don't know why having them would be a problem. Maybe for space issues, is that what you're thinking? Or the knowledge?
When you are doing the inference and you are using, so the user
All right,
yes. changes his mind. He's not
right.
thinking about using that trick.
Right.
And now you're doing the inference using
right.
I think it would be a case where you have kind of a in-memory inference.
Yes.
Where you overlay temporary data and then you throw everything out after.
Yeah. So just remember, like, we are trying to answer the question the user just asked, right? So we just created this triple and then we are running, all the other background information along with the new triple. But that's a good question. We haven't actually thought about that. So thanks.
We don't have access to the Watson Conversation Systems. What are the pieces that we need to build by ourselves? And are there any open source alternatives?
I know of one system called wit.ai. I believe it's open source, but I'm not 100% sure. So that's another alternative to Watson Conversation Service. And I think there's so many other systems out there that you might want to look into. Sure.
It's about the rules.
Yeah.
Are they handwritten tools?
Yes.
So if we move to a new domain, then doesn't mean that there'll be rules available. Someone will write them.
Right. So the rules are actually part of the chat application. So the developers of the app will write those rules. And then once the user interacts with the app, those triples will get generated. And then you run those triples against those rules to come up with certain assertions. Yeah.
Are you allowed to consider the possibility that the rules are wrong or like inefficient in some way? Like they could, like if like people are like consistently ignoring what the rules say is like the proper thing, is the response that they're just not using the app right, or that the rules are based on like faulty reasoning?
So like there are two aspects to that, right? So one, the rules can be incorrect, as in they're not doing anything. Are you talking about those kind of things, or kind of useless rules? Like, they're not doing anything.
Rules that, so like, if like the weight classification sugar limit is wrong because it doesn't also take into account like your I don't know, like some other piece of information that in addition to your weight limit, then like then using that rule could give you bad recommendations about whether or not it's safe to eat it now.
Right. So I would equate that to writing bad code, right? So the developer has to fix up the rules in that case. But are you thinking more or less in terms of getting users' feedback to say?
Yeah. So like if like some rules are like consistently ignored, is that like the sort of feedback you would want to? Right.
So we have thought about giving reasonings behind certain justification, so that the user can actually see like why I was given that recommendation. And based on that, I guess the user can say that the rules are wrong. But I don't know how we can correct that in the system. Yeah, but that's a good thought. Like, we should think about that. Yeah, John.
Well, a little bit related to that question, where are you getting nutritional advice from in developing the structure and in the rules embedded in it?
Right. So we are hoping to get reputable data from either medical professionals. Right now, we're actually getting it from websites that we think are reputable, but when this becomes production level, yeah, we probably have to vet that information from somebody who knows about the domain.
Just to be clear, she's just showing examples of the technology.
Yeah.
So, for example, our system will never ever make a recommendation by law, right? So it will never say no, don't eat the apple. It will say this page would imply you shouldn't eat that apple, right?
Yeah.
So for now, the reputability is based on the provenance, and that's crucial. We can't move away from it. If we actually started talking to someone about a model, if we start talking to health providers, one of the things we're going to have to work in is how to do that. Or we're going to have to bite the bullet and get FDA approval and go through clinical trials.
Yeah.
Well, which we're hoping not
the
to do.
specific example in this case is that the rules appear to equate the sugar in a candy bar with the sugar in an apple. And that's
right. That's what I mean, but these are just simple examples.
Yes.
Right.
Yeah.
And to be fair, the sugar in an apple is the same as the sugar in a candy bar.
So,
it out and put in.
But it has other things like fiber and stuff. Yeah. Yeah.
So just going off like what Alex said, so maybe it might be worth taking like data on like whether a user did ignore what you said, and maybe like obviously if you have like very small user base, that's like no data.
Right.
Like if you like collected that, maybe then you could draw trends from that. Like maybe they actually know more about themselves. It's like it might be useful.
Right. Yeah. Yeah. Definitely. Yeah. Thanks.
Yeah. Our goal is eventually to have enough data we can do cohorts, we can do tracking, we can do that. So I don't know how, I'm sorry, I came late and I don't know how much you gave background on sort of the overall.
I gave like a minute.
Yeah. So given that we're just in the process of defining some of that background, but roughly speaking, the goal of this part of the project is something that's aimed at helping the person do their own health to maintain, to avoid a chronic condition. That's why a lot of our examples are in diabetes and pre-diabetes. So we'd like someone who's worried about developing diabetes to be able to help themselves not get it. Okay. We're going to have to study incentives. We're going to have to, so we're working with some of the campus behavioral economists and things. We're going to do user studies. We're doing again, this is just the technology base of a small piece of a much larger. Half of the project, the other half is going after clinician advice in show is that the same technology base may enable some of these things. So essentially, another way to say it is we're showing IBM how analytics, learning, and semantics improve these technologies, which they would then deploy in the app space with their medical partners. So we're not really, at least in the short term, responsible for getting the quote medically correct stuff on the floor. On the other hand, if the stuff looks stupid, no one's going to use it. So we have to be sweet spot in there in terms of just being able to get people interested in using it enough that we can get the data to make it better and all those kind of things.
So this is building on what Hannah asked and actually what Jim was just saying. I was wondering if there's the sort of feeding back into the knowledge graph for multiple different purposes, one of them being sort of the clinician dashboard, that sort of thing where you're and then sort of the reverse dialogue system, which is how do you inform, well, first the monitoring or administrative one where you've got this patient, what advice do you want to give them, or do you want to give them this advice based on this?
No, we're not giving any advice.
Well, I know. No, that's not what I was saying. It was prompting the clinician to give the advice. That's not what was going on. But also, of course, you know, the analytics side, which is just accumulating this. I think the question about policy as well. If you're accumulating that data and feeding it back into the knowledge graph, do you anticipate rules that govern even what goes in and what doesn't go in? Sort of thing.
Yeah.
I mean, but do you, just so that I have a clearer grasp, so your iPhone app that uses MyFitnessPal,
Right.
and then accesses all of this Watson,
right?
Right. Okay.
HealthKit and
Right,
possibly
and
whatever other
so
apps you'll give us access to. Yeah.
okay. Exactly. So yeah. So where does HIPAA fit into that?
Not a problem at all, as long as we have informed consent if we're doing it experimentally,
Okay.
and consent if we're doing it non-experimentally.
Not giving advice.
But where we can't share, but we can't share your data elsewhere, right? Without some kind of aggregation, et cetera, et cetera. So there's no HIPAA issue if you give me permission to look at something.
Okay.
There's a HIPAA issue if I give it to someone else to look at.
And you can mine it other ways, right? Okay.
Yeah, that's where we're going to have to go, at least temporarily. And then, and again, you know, if you had, so like, for example, IBM has hundreds of millions of electronic health records that we can't touch.
Right.
But if we can develop this technology and show them how to do something, they can run it on their health records, or they can hire one of our team members as an intern to run it on their things, et cetera, et cetera.
Okay.
We can conceivably someday get some of the aggregate stuff back, but even that's problematic at the moment. So,
Okay.
Yeah,
a lot of this depends whether John Kelly or the lawyers win in terms of the interaction. Right now, the lawyers are ahead.
Yeah, and also the data doesn't leave the phone, so that's another thing that we don't have to worry about. Yeah.
Is there an IoT aspect to this at all?
Yes.
Well,
right.
So this example, okay? Is it okay for me to eat this gala apple?
Right.
Well, not the gala apple, but maybe the banana that you've got right next to it in the refrigerator.
See, that's the, I was thinking of the refrigerator database. You know, there are refrigerators now that literally, like, right, you access from your phone and say, you know, do I have this in my fridge? And it looks in your fridge for you.
Well, I'll give you a better example, right? We are making the assumption that by 5 years from now, you will have blood sugar monitoring as a passive thing without requiring a direct act, and that we will have access to it through your phone, right? Even if that's not a true statement, we can make that assumption because IBM will be tracking that technology if it's not 2 years or 4 years, 6 years, you know. So we know that technology is coming. So for example, we're not going to work on the active sensing part of that. We're going to work on the integrating the sensing part of it, right? Your BMI, right? There's a big discussion going on right now about recomputing some of these goals and things, and also how you personalize them and things like that. Somebody's going to have to tell us, who has medical authority, this is what you would use the numbers. So we're going to show that given those numbers, we could do the appropriate thing. So again, we have to be fairly careful about what we do as a university versus, we're not a medical school.
Right.
But again, our goal is mostly proofs of concepts that could then be taken by our industrial partner to deeper things. At least that's what we're hoping. There were some other people in our management structure very high up in our university who would like to see it go far more than that. And again, a lot of that will depend on where we can go.
Cool.
So there's two parts of this project. One which focuses more on the actual interactive part. One which was focused much more on the deeper data representations for medical stuff. And again, we want to show them both those things and that they could go together. But we're not actually going to put them together, at least in the current plan, because you wouldn't give a patient-facing. So the second project is probably going to be fairly deep breast cancer information at a oncologist level. You're not going to put that in front of the patient directly. You might mine that, use that to make some decisions that would then feed to an app like this one to help somebody who is trying to do that. So again, we have to, we're still grappling with so for the first part of the project, we're 4 months into it. And for the second part of the project, we're less than a week into the official section. So again, but we've been doing a lot of planning, thinking, working with IBM. We have, some, personas to test against. So again, it's a things. We're also, again, looking at other technologies in this space. So again, I don't know if you talked about any of that, but for example, we have someone else who's looking at some of the deep learning stuff for how we might use that. So they were planning to do that for question answering. And I've said, not under this funding. What you could do under this funding is try to go from these kind of patterns, right, which we need to be able to make it interact with the other part of the world, which, by the way, no one has yet done in that those that we have found yet, that kind of thing. So again, we're looking at, both what are some of the off-the-shelf technologies, what are some of the cutting-edge technologies together, and that's what we as a university can offer to IBM, is the experimentation. You can see what Oshani's been talking about is the first step, where a technology we understand extremely well at Rensselaer has not yet been rolled into this kind of domain.
Yeah.
At least that's what I'm hoping when I tell Dr. Jackson next week that we're doing. She'll say, okay.
With a smile.
2 weeks.
So it's after 7, so I think we should thank Oshani and then.
And thank you all. Thanks for the great feedback.